Good morning, everyone. I am Dr. Gaurav Sahu, Assistant Professor, Department of Mechanical Engineering, SIRT Bhopal. Today, we are here to discuss on the topic how to draw shear force diagram. Dear students, it is a part of strength of material mechanical engineering third semester, and the SF diagrams are generally find helps to find out the value of shear force in the beam. So let us start with the question that how to draw a shear force diagram or how to find a shear force value. So here we are having a question that how to calculate a shear force value. We are having you can say that we are having a beam. That beam is a simply supported beam on the point A and B, on which the 20 kilonewton per meter UDL is distributed over the span of 4 meter, and a point load is also applied of 10 kilonewton. The total span of beam is 10 meters. So firstly, we will calculate the reaction forces at point A and B. It is very necessary because reaction forces are not shown here. Then notation, the sign notation, we will be using this one. Upward forces are termed as positive, rightward forces are termed as positive, and all the moments in the anti-clockwise direction are termed as positive in case of finding out the reactions. So let us start with taking moment about B. Let us consider this beam as a stick fixed at a point B. Now, if it is fixed at a point B and every forces which are here will apply some kind of force on it, resulting in a moment. So, moment is nothing but a force into perpendicular distance. If we take up upward direction RA, so RA will move the stick in clockwise direction, opposite to this sign. So that's why RA is negative. The total distance of RA from fixed point is 10. So that's why minus RA into 10. 20 kilonewton per meter. Firstly, we have to convert this 20 kilonewton into point load by multiplying with the distance over which the UDL is floated on, 20 into 4. Then it is a rule of converting UDL into point load is that after conversion the UDL into point load, the point load is segmented at the midpoint of the span of UDL. So span of UDL is 4 meter. So at 2 meters, we will apply the point load after converting this 20 into 4 point load. So the total distance of this mid value from this B point is to 2 plus 4, 6, and here it will be 2. Okay, so 8. So 20 into 4 into 8 plus 10 into 2. 10 downward force, 2 meter this force, this distance, sorry, to 20 into 2. So after calculation, you will get the value of RA, that is 66 kilonewton. Now let us find out the value of RB. As per equilibrium, all the upward forces is equal to all the downward forces. So upward forces are RA plus RB, and downward forces are 20 into 4 is that you have to convert this UDL into 0.4 plus 10. Okay. So putting the value of A, we'll get the value of RB 24 kilonewton. So now you have RA as well as RB. Now let us start how to find the shear force value at each and every point in this span of P. We'll follow this notation for the shear force. Left toward the section, it will be positive if upward, and on the right toward section, it will be positive when it is downward. So here is different notation we use in shear force. So let us draw the section. Section is usually made between two loads, two supports, or across a UDL. So here we are finding out first UDL. So we'll draw a section. Generally, we start working with the left point as a fixed point or a reference point. Everything is calculated from the left in general. You can also calculate from the right, but it is better to take the left as a reference position. Name of this section is X1, X1. Distance of X1 section from fixed point A is small x. Shear force as AC segment. Let us consider section X1, X1. The shear force equation will be RA in upward direction, so it is positive, okay, and 20 into X because this UDL is floated in the area of X length only, so 20 into X. is the value of this segment's UDL value. So here it is a shear force equation for segment AC. Now applying the limit is that at the reference value is 0, x is equal to 0, and at point C the reference value from 0 will be start and end at the 4. So at a is equal to 0 and x4 is equal to the value of C. So after putting x is equal to 0 in equation number 1, we are getting SFA 66 kilonewton. Okay, and at SFC is that at this point the shear force is minus 14 kilonewton. So now draw another section is that between this point and this load. So this point and this load. We have already inculcated this section. So now we'll move further from the reference point and we are getting 10 kilonewton point load downwards. So we'll draw the section X2 here. Now the distance of section X2 from the point X, again it will be considered small x. Shear force for segment CD in the section X2, X2. Shear force equation will be RA in upward direction, so positive, and now 20 will be multiplied with 4 meters. So 20 into 4 downward is the value of this UDL. So 20 into 4 here we are seeing. Now at FC the x value is 4 and SF at point at D the value of x will be 8 meters. So we have both the values is that x is equal to 4 and x is equal to 8. SFC by putting the value of x is equal to 4 in equation 1 is that in SF equation which is null and void because here we are not finding any x value to get putting. This is multiplication sign, this is not the sign of x. Okay, remember it. So it is just a formality to put the limit, but limit is not applied over here. So we are getting the direct values by putting the RA value minus 14 kilonewton at point C, and at point D by putting the value of 66 here, again we are getting the minus 14 value. So at C and D both we are getting the value minus 14 kilonewton. Now let us move further away from the reference point beyond the point load D. We are drawing the section X3, X3. The value of X3 from the reference point will be again small x, segment DB, section X3, X3. Shear force equation will be RA positive minus 20 into 4 downwards and 10 into nothing because 10 is a point load. So it is again minus. These two are minus because acting downward in the section's left part according to this sign convention. Putting x is equal to D is equal to 8. We are putting the value, but again it is null and void because it is not having any value of x. This is not x, this is multiplication sign, remember. So we are getting 24 minus 24 kilonewton value by putting only just RA in the shear force equation for the section segment DB. At point B, the total length is 10, x is equal to 10, but again it is null and void to use here, x is equal to 10. So at SFB is equal to minus 24 kilonewton. So these are all the values of shear force at the point A, C, D, B. You can easily see it over here. Now let us move further to draw the shear force diagram. So the value of shear force at A is positive 66. The value of shear force at C is minus 14. The value of shear force, you can say that in both the C point SFC, it is minus 14, and at D it is in segment CD it is minus 14, and for segment DB it is minus 24 because of this load. This load is applied, so C minus 14, D minus 14, but for the segment DB, the shear force value for point D is minus 24 because of this load. So there is a difference of 10 kilonewton. At point B, the value is minus 24. So you can easily check it is minus 24. So here we have drawn the shear force diagram. In our next video, we will learn how to draw the bending moment diagram for this beam. So you can check over here, and this point where the positive sign goes to a negative sign, we will have a 0. So this is known as zero shear position, which is very much significant in calculating the bending moment. So dear students, this was all about how to calculate the shear force value. Thank you.